science of dreams. Hello, welcome to Sleepy History and Mysteries channel. We're going to explore one of the most mysterious and universal experiences that connects every human being who has ever lived: dreams. Those strange, vivid, sometimes beautiful, sometimes puzzling narratives that unfold in our minds while we sleep. We'll look at what science has discovered about why we dream, what happens in our brains during different types of dreams, how dreams have been studied throughout history, and what all of this reveals about consciousness itself. This is a topic that touches on neuroscience, psychology, biology, and even philosophy. We'll move through it slowly and carefully, examining the mechanisms that create dreams, the stages of sleep where they occur, the theories about their purpose, and the fascinating stories of the researchers who dedicated their lives to understanding this nightly phenomenon. So settle in, get comfortable, and let's begin this journey into the science of dreams, the ancient mystery of dreams. Long before modern neuroscience, humans were captivated by dreams. Ancient civilizations across the world developed elaborate systems for interpreting them, believing dreams to be messages from gods, glimpses of the future, or windows into hidden realms of reality. The ancient Egyptians, as far back as 2000 BCE, kept dream books, collections of common dream symbols, and their supposed meanings. They believed that dreams were communications from the divine, and they built special temples where people could go to receive dreams with prophetic significance. These dream temples were places of ritual sleep, where priests would interpret the visions that came to visitors during the night. The practice was so important to Egyptian culture that they dedicated entire structures and religious offices to the interpretation of dreams. In ancient Greece, similar practices existed. The physician Hippocrates, often called the father of medicine, believed that dreams could reveal information about a person's physical health. He thought that certain dream images might indicate imbalances in the body's humors, the fluids that Greeks believed governed health and temperament. A dream of fire, for instance, might suggest excess heat in the body, while dreams of water could indicate an imbalance of phlegm. The philosopher Aristotle took a more naturalistic approach, writing around 350 BCE. He proposed that dreams were not divine messages, but rather products of the mind processing sensory experiences from waking life. This was a remarkably modern insight for its time. Aristotle recognized that dreams often incorporated elements from recent experiences, distorted and recombined in strange ways. He was one of the first to suggest that dreams had a physiological rather than supernatural origin. In his treatise on dreams, he even noted that sometimes when one is asleep, there is something in consciousness which declares that what presents itself is but a dream. In ancient Rome, dreams held political significance. Important decisions, including military campaigns, were sometimes influenced by the dreams of leaders. The Roman senator and orator Cicero wrote about dreams, expressing skepticism about their prophetic power, but acknowledging their psychological importance. He recognized that dreams reflected the concerns and emotions of the dreamer, a notion that would resurface many centuries later in psychological theories. Across the world, in ancient China, dreams were also taken seriously. Chinese philosophers and physicians developed theories linking dreams to the balance of yin and yang, the complementary forces they believed. Dreams of ascending mountains or flying were associated with yang energy, representing activity and light, while dreams of descending into water or darkness were linked to yin, representing rest and receptivity governed all existence. Indigenous cultures around the world developed their own rich traditions of dream interpretation and use. Many Native American tribes held dreams in high regard, sometimes using them to guide major life decisions or to gain spiritual insight.
Some cultures practiced what we would now call lucid dreaming, the ability to become aware within a dream and potentially influence its course. These practices were often integrated into coming-of-age ceremonies or healing rituals. What all these ancient approaches had in common was a recognition that dreams mattered, that they revealed something important, even if there was disagreement about exactly what that something was. This respect for dreams as meaningful experiences would eventually give way to scientific investigation, but the questions remained largely the same. Why do we dream? What do dreams mean? And what can they tell us about the mind? The birth of dream science, the scientific study of dreams, began in earnest in the late 19th century, though it took a winding path before arriving at the neuroscience we know today. In 1899, Sigmund Freud published The Interpretation of Dreams, a work that would profoundly influence not just psychology but all of Western culture. Freud proposed that dreams were the royal road to the unconscious, a window into hidden desires, fears, and conflicts that the conscious mind kept suppressed during waking hours. According to Freud's theory, dreams had both manifest content, the actual images and narratives we remember, and latent content, the hidden psychological meaning beneath the surface. He believed that dreams used symbolism to disguise wishes that would be unacceptable to the conscious mind, particularly wishes of a sexual or aggressive nature. A dream about riding a horse in Freudian interpretation might symbolize something quite different from its literal content. Freud's approach was revolutionary because it treated dreams as psychologically meaningful rather than random nonsense. However, his methods were not scientific in the modern sense. His interpretations were based on his clinical observations and theoretical framework, not on controlled experiments or measurable data. Many of his specific claims about dream symbolism have not held up under scientific scrutiny. Nevertheless, Freud's work established dreams as a legitimate subject for psychological inquiry and influenced many researchers who came after him, even those who disagreed with his theories. He made one particularly important contribution. He suggested that the repository of dreaming was within the mind of each person, not something imposed from outside. This shifted the focus toward understanding dreams as brain-generated phenomena. One of Freud's early followers who later broke away was Carl Jung, a Swiss psychiatrist who developed his own theory of dreams. Jung believed that dreams reflected not just personal unconscious material, but also what he called the collective unconscious, a shared repository of human experiences and symbols accumulated over evolutionary time. Jung saw dreams as attempts at compensation, balancing out one-sided attitudes or perspectives from waking life. If someone was too rational and logical during the day, their dreams might be filled with irrational, emotional, or mystical content to restore psychological balance. Jung also believed dreams could be prospective, pointing toward future psychological development rather than just processing past experiences. He thought certain symbols in dreams reflected universal archetypes with meanings that are similar for all people regardless of culture or location. Like Freud, Jung's theories were based more on clinical observation and philosophical reasoning than on experimental evidence. But both men established the idea that dreams deserved serious attention and might reveal important truths about the human psyche. They also both focused intensely on dream content, on the actual stories and images people experienced, which remains an important aspect of dream research today. The real breakthrough in dream science came in the 1950s, when researchers discovered a way to observe dreams more directly through the study of sleep itself. This would transform dreams from a purely subjective, philosophical topic into something that could be measured, recorded, and studied with scientific rigor. The discovery of REM sleep in 1952. A graduate student named Eugene Aserinsky was working in the laboratory of Nathaniel Kleitman at the University of Chicago. Kleitman was already a distinguished sleep researcher, known as the father of American sleep research. He had spent years studying sleep patterns and was interested in understanding the different stages of sleep. Aserinsky was assigned to observe the eye movements of sleeping infants. This was painstaking work, involving long nights of watching children sleep. The task might seem mundane, but Aserinsky noticed something unexpected. At certain times during sleep, the infant's eyes moved rapidly beneath their closed eyelids. These rapid eye movements occurred in periodic bursts throughout the night. Curious about whether this pattern continued into adulthood, Aserinsky began studying adult sleepers. His first subject was his own 8-year-old son, Armand. He used an electroencephalogram, or EEG, a machine that records electrical activity in the brain, along with sensors to detect eye movements. What he found was remarkable. Throughout the night, sleepers alternated between periods of quiet sleep, when the eyes were still and brain activity was slow, and periods of active sleep, characterized by rapid eye movements and brain activity that looked similar to waking patterns. These active periods occurred roughly every 90 minutes and seemed to be associated with something special happening in the brain. Aserinsky and Kleitman decided to wake people during these periods of rapid eye movement to see what they would report. The results were striking. When awakened during rapid eye movement periods, subjects almost always reported vivid dreams. When awakened during quiet sleep, they rarely reported dreams or reported only vague, thought-like experiences. This discovery, published in September 1953 in the journal Science, fundamentally changed sleep research. It revealed that sleep was not a uniform state of unconsciousness, but rather a complex process with distinct stages, and it provided a biological marker for dreaming. Researchers now had a way to study dreams objectively, by monitoring the sleeper's brain and body rather than relying solely on subjective reports. The stage of sleep with rapid eye movements became known as REM sleep, short for rapid eye movement sleep. The other stages became known collectively as non-REM sleep or NREM sleep. This was the beginning of modern sleep science. Aserinsky's path after this discovery was not straightforward. He left the University of Chicago in 1953 and, remarkably, turned his back on sleep research for a time. He went to the University of Washington in Seattle and spent a year studying the effects of electrical currents on salmon. Then he landed a faculty position at Jefferson Medical College in Philadelphia, where he explored high-frequency brain waves and studied animal respiration. It wasn't until the early 1960s that his son Armand urged him to return to the field he had helped start. Meanwhile, William Dement, who had been a medical student and then a research fellow in Kleitman's laboratory starting in 1952, continued the work. Dement helped run overnight sessions for Aserinsky's experiments and later coined the term rapid eye movement sleep or REM sleep. He went on to establish the first sleep clinic at Stanford University and became one of the most prominent figures in sleep research. The discovery of REM sleep opened up an entirely new field of investigation. Researchers could now chart the sequence of sleep patterns over the course of a night, understanding when dreams were most likely to occur and how the brain changed during different sleep stages. In the years following this discovery, researchers began mapping out the architecture of sleep in detail, identifying the different stages and understanding how they cycle throughout the night. This work would reveal that sleep is far more complex and active than anyone had previously imagined. The architecture of sleep: when you fall asleep at night, your brain doesn't simply shut down. Instead, it embarks on a carefully orchestrated journey through several distinct stages, each with its own characteristic patterns of brain activity, body state, and mental experience. The sleep cycle begins with non-REM sleep, which itself has 3 stages. Modern sleep classification identifies these as Stage 1, Stage 2, and Stage 3, though older systems sometimes divided what is now Stage 3 into 2 separate stages. Stage 1 is the lightest stage of sleep, the transition between waking and sleeping. It typically lasts only a few minutes as you first drift off. During Stage 1, your brain waves slow down from the rapid beta waves of wakefulness to slower alpha waves, and then to even slower theta waves. Your eyes move slowly beneath your closed lids, your muscles begin to relax, and you might experience that sensation of suddenly falling and jerking awake, a phenomenon called a hypnic jerk. If someone calls your name during Stage 1, you'll probably wake up easily. You might not even be sure whether you were asleep or just resting with your eyes closed. This stage usually lasts between 5 and 10 minutes during a typical night's sleep. From Stage 1, you progress to Stage 2, a period of light but deeper sleep. During Stage 2, your heart rate slows down, your breathing becomes more regular, your body temperature drops slightly, and your eyes stop moving. Your brain waves continue to slow, but they're punctuated by 2 distinctive patterns that researchers can identify on an EEG. The first is called sleep spindles, brief bursts of rapid brain activity that last about a second. These sleep spindles occur at a frequency of about 11 to 16 Hz, which is quite fast compared to the background brain activity during this stage. Research has indicated that sleep spindles play a critical role in memory consolidation and in protecting sleep from external disturbances. They seem to help strengthen the connections between neurons that store new memories. The second distinctive pattern is called K-complexes, large, slow brain waves that appear spontaneously or in response to external sounds or other stimuli. These K-complexes are the largest brain waves seen in humans during normal sleep. Studies using functional MRI have shown that K-complexes activate brain regions involved in memory processing and in filtering out sensory information that isn't important enough to wake you up. Stage 2 sleep makes up a significant portion of your total sleep time, approximately 45 to 50% of a full night's sleep. During a typical sleep cycle, you might spend 10 to 25 minutes in stage 2 before moving deeper. From stage 2, you descend into stage 3, the deepest stage of NREM sleep, sometimes called slow wave sleep or deep sleep. During stage 3, your brain produces large, slow brain waves called delta waves. These delta waves have a very low frequency, slower than the waves in lighter sleep stages, but they have high amplitude, meaning they're powerful. During deep sleep, your heart rate and breathing reach their slowest rates of the night. Your blood pressure drops. Your muscles are deeply relaxed. If someone were to try to wake you during stage 3 sleep, it would be quite difficult, and if they succeeded, you would likely feel groggy and disoriented for several minutes afterward. This grogginess is called sleep inertia, and it can last up to 30 minutes. Stage 3 sleep is incredibly important for physical restoration. This is when your body does much of its repair work. Growth hormone is released during deep sleep, helping to repair tissues, build bone and muscle, and strengthen the immune system. Children and teenagers spend more time in deep sleep than adults do, which makes sense given how much physical growth and development occurs during these years. For adults, stage 3 sleep makes up about 20 to 25% of total sleep time, which translates to roughly 1.5 to 2 hours during a full night of sleep. The deepest periods of stage 3 sleep tend to occur during the first half of the night. As the night progresses, stage 3 periods become shorter and may disappear entirely during later sleep cycles. The amount of deep sleep you get decreases gradually as you age. Older adults spend significantly less time in stage 3 sleep than younger people do, which may contribute to some of the sleep complaints common in older age. After moving through the non-REM stages, your brain doesn't continue into ever deeper sleep. Instead, it cycles back up through stage 2 and then enters an entirely different type of sleep: REM sleep. REM sleep is unlike any of the NREM stages. During REM sleep, your brain becomes highly active, with electrical patterns that closely resemble those seen during wakefulness. This is why REM sleep is sometimes called paradoxical sleep, because the combination of high brain activity and complete muscle relaxation seems paradoxical. During REM sleep, your eyes move rapidly from side to side beneath your closed eyelids. These are the rapid eye movements that gave this stage its name. Your breathing becomes faster and more irregular. Your heart rate increases. But at the same time, most of your voluntary muscles become temporarily paralyzed, a state called REM atonia. This paralysis prevents you from physically acting out your dreams, which is fortunate given how vivid and active REM dreams can be. The first REM period of the night typically occurs about 90 minutes after you fall asleep and lasts only 10 to 15 minutes. As the night progresses, REM periods become longer and more frequent. The final REM period before waking can last up to an hour. Overall, REM sleep makes up about 20 to 25% of total sleep time in adults, though this percentage is much higher in infants and young children. REM sleep is when the most vivid, narrative, emotionally intense dreams occur. While some mental activity can happen during NREM sleep, particularly during the lighter stages, the elaborate, story-like dreams that we remember most clearly almost always come from REM sleep. A complete cycle through all the sleep stages, from stage 1 through REM, takes about 90 to 120 minutes. During a typical night of 7 to 8 hours of sleep, you'll go through 4 to 6 of these cycles. The cycles aren't identical, though. The first cycle of the night usually has longer periods of deep NREM sleep and a shorter REM period. As the night progresses, you spend less time in deep sleep and more time in REM sleep. This architecture of sleep, with its regular cycling between different stages, is found not just in humans but in all mammals and birds. The fact that it's so highly conserved across species suggests that each stage serves important functions that have been preserved through evolution. The discovery of this sleep architecture opened up countless new questions for researchers. What was happening in the brain during each stage? Why did we need different types of sleep? And most intriguingly for our purposes, why did vivid dreaming occur primarily during REM sleep? What happens in the dreaming brain? To understand what creates dreams, we need to look at what's happening in the brain during REM sleep. The picture that has emerged from decades of research is complex and still not completely understood, but it reveals a fascinating reorganization of brain activity. During REM sleep, certain areas of the brain become highly active while others become relatively quiet. The areas that activate during REM include the limbic system, a group of brain structures involved in emotions and memory. The amygdala, which processes emotions, particularly fear and other strong feelings, is very active during REM sleep. This may explain why dreams can be so emotionally intense. The hippocampus, crucial for forming new memories, is also active during REM sleep. This activity may be related to the memory consolidation that occurs during dreaming, as the brain processes and stores information from the day. Visual areas of the brain, particularly the visual cortex at the back of the head, show increased activity during REM sleep. This makes sense given the vivid visual nature of most dreams. The brain is generating complex visual imagery without any input from the eyes, which are closed and not receiving light. Areas involved in motor control and spatial navigation also activate during REM dreams. When you dream about walking or flying or moving through space, the parts of your brain that would be active during those activities in waking life are actually firing, even though your muscles are paralyzed and you're not moving. But here's what's particularly interesting: the prefrontal cortex, the area at the front of the brain involved in logical thinking, planning, decision-making, and reality testing, shows decreased activity during REM sleep. This deactivation of the prefrontal cortex may explain many of the characteristic features of dreams. Without the prefrontal cortex fully engaged, you don't question the bizarre or impossible things that happen in dreams. You accept that you can fly, or that a friend has turned into a stranger, or that you're simultaneously in your childhood home and your current workplace. The critical thinking and reality monitoring that would normally alert you to inconsistencies or impossibilities are offline. This prefrontal deactivation also affects your memory. The prefrontal cortex is involved in forming certain types of memories, particularly what are called episodic memories, memories of specific events organized in time and place. Without this region fully active, most dreams are quickly forgotten unless you wake up during or immediately after them. The neurotransmitter environment in the brain also changes dramatically during REM sleep. Acetylcholine, a neurotransmitter involved in attention and memory, reaches very high levels during REM sleep, similar to or even higher than waking levels. This increase in acetylcholine may contribute to the vivid, hallucinatory quality of dreams. Meanwhile, other neurotransmitters drop to very low levels during REM sleep. Serotonin and norepinephrine, which help regulate mood and attention during waking hours, are almost completely absent during REM periods. This change in the chemical environment may contribute to the emotional intensity and sometimes illogical quality of dreams. One theory about dreaming, called the activation synthesis hypothesis, was proposed by psychiatrists Alan Hobson and Robert McCarley in the 1970s. They suggested that during REM sleep, the brainstem sends random electrical signals up to the cortex. The cortex then tries to make sense of these random signals by synthesizing them into a narrative, creating the story of a dream. According to this theory, dreams don't have inherent meaning but are simply the brain's attempt to create coherence from random neural firing. While this theory was influential, it has been revised over the years as research has revealed that dreams are less random than Hobson and McCarley initially thought. Dreams do show patterns and often incorporate real memories, concerns, and emotions, suggesting they're not purely random productions. More recent theories have focused on the idea that REM sleep and dreaming may serve specific cognitive functions. One prominent idea is that dreams help with memory consolidation, the process of transferring information from short-term to long-term storage and integrating new experiences with existing knowledge. Studies have shown that people who are allowed to enter REM sleep after learning a new task often show better retention of that task than people who are deprived of REM sleep. This has been demonstrated with various types of learning, from motor skills to emotional memories to spatial navigation. The memory consolidation that happens during REM sleep may be selective, focusing on information that's emotionally important or relevant to current concerns. This could explain why we often dream about things that are worrying us or events that had emotional significance during the day. Another theory suggests that dreams serve an emotional regulation function. According to this view, dreams help us process and manage our emotions, particularly negative ones. The high activity in emotional brain regions during REM sleep, combined with the low levels of norepinephrine, a stress-related neurotransmitter, may create an optimal environment for working through emotional experiences. Research by psychologist Rosalind Cartwright found that people going through divorce who had dreams incorporating both old and new experiences showed better recovery from depression than those who didn't have such dreams. This suggested that dreams might be actively working through emotional difficulties. There's also a threat simulation theory developed by cognitive neuroscientist Antti Raivanchuo. This theory proposes that dreaming evolved as an ancient biological defense mechanism, a way to simulate threatening events and practice responding to them. The idea is that by rehearsing threats in the safe environment of dreams, our ancestors became better prepared to handle real dangers. Supporting this theory is the observation that a large percentage of dreams contain threatening content. Studies analyzing dream content have found that roughly 60 to 70% of dreams include some kind of threat or negative event. The most common dream themes across cultures include being chased or attacked, falling, being unable to move, losing teeth, or experiencing some kind of failure or embarrassment. Of course, dreams also contain many non-threatening elements, and the threat simulation theory doesn't explain all aspects of dreaming. More likely, dreaming serves multiple functions, from memory consolidation to emotional regulation to problem solving. Some researchers have proposed that dreams help with creative thinking and insight. There are numerous anecdotal reports of people solving problems or having creative breakthroughs in dreams. The chemist August Kekulé reportedly figured out the ring structure of benzene after dreaming of a snake biting its own tail. The inventor Elias Howe claimed that a dream helped him solve a problem in designing the sewing machine. While such stories are hard to verify, there's experimental evidence that REM sleep can enhance creative problem solving. Studies have shown that people who enter REM sleep before being retested on creative problems often perform better than those who stay awake or only experience NREM sleep. The looser associations and reduced logical constraints of the dreaming mind may allow for novel connections between ideas. A more recent theory called the overfitted brain hypothesis, proposed by Eric Hole, draws on concepts from machine learning. The idea is that during waking hours, our brains can become too specialized or overfitted to the specific experiences we've had, losing the ability to generalize. Dreams, with their bizarre and unpredictable combinations of elements, may help prevent this overfitting by exposing the brain to unusual situations and maintaining cognitive flexibility. What's clear from all this research is that dreaming is not a purposeless byproduct of sleep, but an active process involving specific patterns of brain activity. The dreaming brain is not simply turned off for resting. It's engaged in complex operations that may serve important cognitive and emotional functions. Dreams and memory. One of the most well-supported ideas about dreaming is that it plays a role in memory. The relationship between sleep, dreams, and memory is intricate and involves both REM and NREM sleep. During sleep, and particularly during certain sleep stages, the brain appears to replay experiences from the day. Researchers have observed this phenomenon directly in studies with animals. When rats learn to navigate a maze, specific neurons in their hippocampus fire in particular patterns. Later, during sleep, those same neurons fire in the same patterns, as if the rat's brain is replaying the maze experience. Similar replay has been observed in human brains using brain imaging techniques. When people learn a task during the day, the same brain regions that were active during learning show activity during subsequent sleep. This neural replay seems to strengthen the memory, making it more stable and better integrated with existing knowledge. But the relationship between dreams and memory is not straightforward. Dreams don't simply replay our experiences like a video recording. Instead, they incorporate fragments of recent experiences, often mixed with older memories, in novel and sometimes bizarre combinations. This mixing and recombining of memories may actually be part of how sleep helps with memory consolidation. By activating related memories together, the brain may be strengthening connections between them, building richer networks of associations. When you dream about your new workplace but it somehow merges with your old school, your brain might be integrating new experiences into existing frameworks of knowledge. Research has shown that the incorporation of waking experiences into dreams follows interesting patterns. Elements from the day often appear in dreams, a phenomenon called the day residue. But there's also something called the dream lag effect, where experiences are more likely to appear in dreams about 5 to 7 days after they occurred than in dreams on the night immediately following the experience. This suggests that memory consolidation is a multi-stage process, and different aspects of an experience may be processed at different times. The immediate replay during sleep right after learning may handle one type of processing, while later incorporation into dreams may serve a different function, perhaps related to integrating those memories more deeply or connecting them to emotional themes. Not all memories are equally likely to appear in dreams. Emotionally significant experiences are more likely to be incorporated into dreams than neutral ones. This makes sense if dreams serve an emotional regulation function as well as a memory function. The brain may be prioritizing the processing of experiences that have emotional weight. Interestingly, while fragments of experiences often appear in dreams, it's rare to have a dream that's a straightforward replay of an event. Even when we dream about real people or places, they're usually transformed in some way, combined with other elements, or placed in unusual contexts. This transformation may be important for the memory consolidation process, allowing the brain to extract the essential or emotional elements of an experience while discarding irrelevant details. People with damage to certain brain areas show interesting changes in both dreaming and memory. Neurologist Mark Soames studied patients with various types of brain damage and found that damage to specific regions could affect dreaming in different ways. Damage to the deep frontal white matter could eliminate dreaming entirely, while damage to other areas might change the character of dreams without eliminating them. Some of these same brain regions are crucial for memory formation, supporting the idea that dreaming and memory are closely linked. Patients who lose the ability to dream often also have memory problems, though the relationship isn't always simple or direct. The connection between dreams and memory becomes especially clear when we look at sleep deprivation. When people are deprived of sleep, particularly REM sleep, their ability to form and consolidate new memories is impaired. They have more difficulty learning new information, and they show poorer retention of things they've already learned. Studies have found that even a single night of disrupted sleep can affect memory consolidation. The impact is even more pronounced when sleep deprivation continues over multiple nights. Students who pull all-nighters before exams often perform worse than those who get adequate sleep, not just because they're tired during the test, but because the information they tried to learn wasn't properly consolidated into memory. There's also evidence that specific types of learning benefit from specific types of sleep. Motor skills and procedural learning, like learning to play a musical instrument or improving at a sport, seem to benefit particularly from stage 2 NREM sleep, especially the sleep spindles that characterize this stage. Declarative learning, like memorizing facts or learning vocabulary, may benefit more from slow-wave sleep. And emotional memory processing seems to depend heavily on REM sleep. This suggests that a full night's sleep, with all its different stages occurring in their proper sequence and duration, is important for different aspects of memory consolidation. You can't just sleep for 4 hours and expect to get the same memory benefits as sleeping for 8 hours, because you'll miss out on the later REM periods that become longer as the night progresses. The relationship between dreams and memory also has practical implications. Some research suggests that thinking about things you want to remember before falling asleep may increase the likelihood that they'll be consolidated during sleep. This targeted memory reactivation can be enhanced by pairing information with specific cues, like sounds or smells, and then presenting those same cues during sleep. There are even experimental techniques where researchers have successfully influenced dream content and enhanced specific memories by presenting relevant cues during sleep. While these techniques are still experimental, they hint at potential future applications for education and therapy. The content of dreams: what do people actually dream about? This question has fascinated psychologists and neuroscientists for more than a century, and researchers have developed sophisticated methods for analyzing dream content. One of the most influential systems for categorizing dream content was developed by psychologists Calvin Hall and Robert Van de Castle in the 1960s. They collected thousands of dream reports and systematically coded them for various features: characters who appeared, settings, objects, activities, emotions, social interactions, and so on. Using this system, researchers have been able to identify patterns in what people dream about. Some of these patterns are remarkably consistent across different people and even across different cultures. Characters in dreams are often people the dreamer knows. About half of the characters in typical dreams are familiar to the dreamer, while the other half are strangers or unidentified figures. Among the familiar characters, friends and family members appear most frequently. The dreamer themselves is almost always present in their own dreams, though occasionally people report dreams viewed from a third-person perspective. Settings in dreams usually involve familiar places, though they're often transformed or combined in impossible ways. You might dream you're in your current home, but it has the layout of your childhood house, or you're at your workplace, but it's located on a beach. Despite these transformations, the settings rarely feel random. They're usually places that have some connection to the dreamer's life or concerns. The emotions experienced in dreams tend toward the negative more often than the positive. Anxiety is the most commonly reported emotion in dreams, followed by apprehension and confusion. Fear is common in nightmares, which we'll discuss more shortly. But positive emotions also occur in dreams. Joy, excitement, and affection appear regularly, just somewhat less frequently than negative emotions. One consistent finding is what researchers call the continuity hypothesis. Dreams tend to reflect our waking life concerns, relationships, and activities. People dream about things that matter to them. Students dream about exams. Parents dream about their children. If you're going through a stressful time at work, you're likely to have work-related dreams. This doesn't mean dreams are simple copies of waking life. They're not. The continuity is more subtle, involving themes and emotions rather than specific events. If you're anxious about a presentation at work, you might dream about being unprepared, but the dream might place you in a school setting from your past rather than your actual workplace. There's also evidence that dreams reflect personality traits and individual differences. People who are more anxious in waking life tend to have more anxiety in their dreams. Creative people often report more unusual or vivid dreams. Introverts and extroverts dream about social situations differently. Gender differences in dream content have been observed in some studies, though these differences may reflect cultural factors as much as biological ones. Some research suggests that women report remembering more dreams than men and may include more familiar characters and indoor settings in their dreams, while men may report more physical aggression and outdoor settings. However, these are statistical tendencies with considerable individual variation, not absolute rules. Age also affects dream content. Children's dreams tend to be simpler and shorter than adult dreams. Young children often dream about animals more frequently than adults do. As children grow older, their dreams become more complex, incorporating more characters, more social interactions, and more nuanced emotions. There's an interesting developmental pattern in the ability to report dreams. Very young children, younger than about 5 or 6 years old, report fewer dreams and have difficulty describing them when they do. This doesn't necessarily mean they're not having dream experiences, but their ability to recall and articulate those experiences is limited. One fascinating finding from developmental dream research is that children's ability to report dreams correlates most strongly with their visuospatial skills, particularly as measured by tasks like the block design test. This suggests that dreaming may depend heavily on the brain's ability to create and manipulate mental imagery, which develops gradually as the parietal lobes mature and become fully myelinated around age 7. Certain dream themes appear with surprising frequency across different people and cultures. Being chased or pursued is one of the most commonly reported dream themes worldwide. Falling is another universal theme. Dreams about being unprepared for a test or important event are extremely common among students and even among adults long after they've finished school. Flying dreams are reported by many people, though not everyone has them. For those who do, flying dreams are often reported as positive experiences, associated with feelings of freedom and exhilaration. Being unable to move, sometimes described as sleep paralysis, is another common theme and is usually experienced as negative or frightening. These common themes have led to speculation about whether certain dream content might be universal to humans, possibly reflecting evolutionarily old concerns like avoiding threats or achieving goals. The fact that being chased is such a common dream theme might relate to the threat simulation theory, suggesting our brains naturally rehearse escape scenarios. Dreams can also reflect cultural context. People in different cultures do show some variations in dream content, influenced by their daily lives and cultural concerns. Someone living in a traditional agricultural society might have different recurring dream themes than someone in a modern urban environment, though the underlying emotions and narrative structures often show similarities. Nightmares and disturbed dreaming. While most dreams are neutral or mildly emotional, some dreams are intensely negative experiences that we call nightmares. Understanding nightmares has both scientific and clinical importance. Nightmares are defined as vivid, emotionally intense dreams that typically evoke fear, anxiety, or distress and often cause the dreamer to wake up. They occur during REM sleep and are distinguished from night terrors, which happen during deep NREM sleep and involve different mechanisms. Research on nightmare content has revealed some consistent patterns. A comprehensive study that collected dream reports from hundreds of participants over several weeks found that physical aggression was the most frequently reported theme in nightmares. Being chased, experiencing threats, or witnessing violence appeared frequently. Other common nightmare themes included interpersonal conflicts, failure or helplessness, health concerns and illness, accidents and disasters, and being late or unprepared. The frequency of nightmares varies considerably across the population. Studies suggest that about 85% of adults have at least one nightmare per year, while about 8 to 29% have nightmares monthly. Frequent nightmares, defined as occurring weekly or more often, affect only about 2 to 6% of the general adult population, though the rates are much higher in people with certain mental health conditions. Children and adolescents tend to experience nightmares more frequently than adults. The highest frequency appears to be in children between the ages of 3 and 6. As people move into adulthood, nightmare frequency typically declines, though some individuals continue to have them regularly throughout life. Several factors can increase nightmare frequency. Stress and anxiety are among the strongest predictors. People going through difficult life events, relationship problems, work stress, or major transitions often report more frequent nightmares. The nightmares don't necessarily depict the stressful situation directly, but they tend to incorporate themes of threat, loss, or helplessness that relate to the person's emotional state. Certain medications can affect dreaming and increase nightmares. Beta blockers used to treat high blood pressure can influence REM sleep and dream content. Antidepressants, particularly SSRIs, can also affect dreams, sometimes increasing their vividness or emotional intensity. When people stop taking certain medications or substances, including alcohol, they may experience a rebound increase in REM sleep that can lead to more intense dreams and nightmares. Trauma is strongly associated with nightmares. People who have experienced traumatic events, particularly those with post-traumatic stress disorder or PTSD, often suffer from recurrent nightmares. These traumatic nightmares may replay elements of the actual traumatic event, or they may incorporate trauma-related themes in more symbolic ways. The nightmares associated with PTSD can be particularly distressing because they often wake the person in a state of fear or panic, making it difficult to fall back asleep. This can lead to a pattern of sleep avoidance, where the person becomes afraid of falling asleep because they anticipate having nightmares. The resulting sleep deprivation can then worsen other PTSD symptoms, creating a difficult cycle. Treatment approaches for nightmares have developed considerably over the years. One effective therapy is called imagery rehearsal therapy. In this approach, the person writes down a recurring nightmare and then consciously rewrites it with a different, less distressing outcome. They then rehearse this new version during the day, imagining it in detail. Studies have shown that this technique can reduce the frequency of nightmares, even though the rehearsal happens while awake. The effectiveness of imagery rehearsal therapy suggests that nightmares aren't simply automatic, unchangeable productions of the sleeping brain. They involve some degree of learned patterns that can be modified. The brain appears to be capable of incorporating the rehearsed, alternative scenarios into the actual dream content. Cognitive behavioral therapy specifically designed for nightmares and sleep disruption has also shown promise. This approach helps people change their thoughts and behaviors around sleep and nightmares, reducing anxiety about sleep and developing better sleep habits. For some people, particularly those with PTSD-related nightmares, a medication called prazosin has shown some benefit. Prazosin is primarily used to treat high blood pressure, but it also affects certain neurotransmitter systems in the brain in ways that may reduce nightmare intensity and frequency. The research on prazosin for nightmares has shown mixed results, with some studies finding significant benefits and others finding modest or no effects. Night terrors, while often confused with nightmares, are quite different. Night terrors occur during stage 3 NREM sleep, usually in the first third of the night. During a night terror, the person may sit up, scream, appear terrified, and show signs of intense fear, such as rapid heart rate, heavy breathing, and sweating. However, they're not actually awake and are not having a dream narrative in the way that REM nightmares involve stories. People experiencing night terrors are typically unresponsive to attempts at comfort and may push others away. Most importantly, when they fully wake up, they usually have no memory or only a vague impression of what happened, unlike nightmares where the dream content is often remembered in detail. Night terrors are most common in children and usually decrease in frequency with age. Another sleep-related phenomenon that can be disturbing is sleep paralysis, which we touched on earlier. Sleep paralysis occurs when a person becomes conscious while their body is still in the state of REM atonia, the muscle paralysis that normally accompanies REM sleep. They're awake or semi-awake, but temporarily unable to move or speak. Sleep paralysis often includes hallucinations, which can be visual, auditory, or sensory. People commonly report feeling a presence in the room, experiencing pressure on the chest, or hearing strange sounds. These experiences can be frightening, especially for people who don't understand what's happening. Sleep paralysis episodes are usually brief, lasting from a few seconds to a couple of minutes. They're more likely to occur when people are sleep deprived, when they sleep on their backs, or when their sleep schedule is irregular. While sleep paralysis can be unsettling, it's not harmful and doesn't indicate any serious medical problem. Understanding what it is can make the experience less frightening when it occurs. Lucid dreaming among the various types of dreams. Lucid dreams hold a special fascination. A lucid dream is one in which the dreamer becomes aware that they're dreaming while the dream is still happening. This awareness can range from a fleeting recognition to full consciousness and the ability to deliberately control the dream narrative. Lucid dreaming has been known about for a long time, with references appearing in ancient texts from various cultures. However, it was often dismissed by Western scientists as impossible or simply misremembered. The idea that someone could be simultaneously asleep and consciously aware seemed contradictory. The scientific validation of lucid dreaming came through an ingenious experiment. Researchers reasoned that if someone was truly conscious during a dream, they might be able to perform a predetermined action that could be detected from outside. Since the eyes move during REM sleep and aren't paralyzed like other muscles, researchers asked experienced lucid dreamers to move their eyes in a specific pattern, left, right, once they became lucid. In 1975, British researcher Keith Hearn conducted the first laboratory study demonstrating this phenomenon. A lucid dreamer named Alan Worsley successfully signaled that he was conscious during a dream by moving his eyes in the agreed-upon pattern. The eye movements were recorded on an EOG, an electrooculagram that tracks eye movements, providing objective evidence that the person was indeed aware during REM sleep. This research was independently replicated by Stephen LaBerge at Stanford University in the early 1980s. LaBerge went on to become one of the leading researchers in the field of lucid dreaming and helped establish it as a legitimate area of scientific inquiry. Studies using brain imaging have revealed that lucid dreaming involves a distinct pattern of brain activity. When people become lucid in a dream, there's increased activity in the prefrontal cortex, the area that's normally deactivated during regular REM sleep. This makes sense as the prefrontal cortex is involved in self-awareness and metacognition, the ability to think about one's own thinking. However, lucid dreaming isn't quite the same as being fully awake. The brain activity during lucid dreaming shows a hybrid pattern, with some features of REM sleep and some features of waking consciousness. It's a unique state that doesn't fit neatly into our usual categories of being either asleep or awake. Not everyone experiences lucid dreams regularly. Surveys suggest that about 55% of people have had at least one lucid dream in their lifetime, while about 23% experience lucid dreams at least once a month. A smaller percentage, perhaps 1% or less, have lucid dreams very frequently, multiple times per week. There appears to be a skill component to lucid dreaming. People can learn to have lucid dreams more frequently through various techniques. One common approach is called reality testing, where you habitually question whether you're awake or dreaming during the day. The idea is that this habit will carry over into dreams, and you'll eventually perform a reality check while dreaming and realize you're in a dream. Another technique is called the mnemonic induction of lucid dreams, or MILD technique, developed by Stephen LaBerge. This involves waking up after about 5 or 6 hours of sleep, staying awake briefly while focusing on your intention to recognize that you're dreaming, and then returning to sleep while holding that intention in mind. Studies have found that this technique can significantly increase the frequency of lucid dreams. Some people use a technique called wake back to bed, where they set an alarm to wake themselves during the night, stay awake for a period ranging from a few minutes to an hour, and then go back to sleep. This often leads directly into REM sleep and can increase the likelihood of lucid dreaming. There's also been research into external cues that might trigger lucidity. Devices have been developed that detect REM sleep and then provide gentle sensory cues, like flashing lights or sounds, intended to be noticed in the dream without waking the person. The results have been mixed, with some people finding these devices helpful and others finding them disruptive. Once someone achieves lucidity in a dream, the degree of control they have varies. Some lucid dreamers report being able to deliberately change dream scenarios, summon specific people or places, or perform impossible actions like flying. Others report that while they're aware they're dreaming, they have little control over the dream narrative, which continues to unfold on its own. The applications of lucid dreaming have been explored in various contexts. Some researchers have investigated whether lucid dreaming could be used for rehearsing skills or creative problem solving. If you can become aware in a dream and deliberately practice a skill, could you improve at that skill in waking life? The evidence is preliminary, but some studies suggest this might be possible for certain types of motor skills. Lucid dreaming has also been explored as a potential treatment for recurring nightmares. If someone can become lucid during a nightmare and recognize that they're dreaming, they might be able to reduce their fear or change the dream's direction. Some therapists have incorporated lucid dreaming techniques into nightmare treatment protocols. However, lucid dreaming isn't necessarily always positive. Some people report that achieving lucidity takes effort and can make their sleep feel less restful. There are also occasional reports of negative lucid dreaming experiences. where the awareness that one is dreaming doesn't prevent fear, or where the attempt to control the dream is unsuccessful and frustrating. The question of what lucid dreaming reveals about consciousness is philosophically intriguing. It demonstrates that consciousness isn't a simple on-off switch but can exist in gradations and hybrid states. It also shows that our sense of reality and our critical thinking abilities are more fragile than we might assume, given how rarely we spontaneously question whether we're dreaming even when experiencing impossible events. Dreams across the lifespan. The nature of dreaming changes throughout human life, from infancy through old age. Understanding these changes provides insight into how dreaming relates to brain development and cognitive function. Newborn infants spend a remarkable amount of time in REM sleep, approximately 8 hours per day, or about 50% of their total sleep time. This is much higher than the 20 to 25% seen in adults. Some researchers believe this high proportion of REM sleep is important for brain development, as REM sleep is associated with neural activity that may help establish and strengthen brain connections. The question of whether newborns actually dream is difficult to answer. They clearly experience REM sleep, with all its characteristic brain activity and rapid eye movements. But dreaming as we understand it, the experience of narrative, imagery, and emotion, likely requires a level of cognitive development that newborns haven't yet achieved. As infants grow into toddlers and young children, their proportion of REM sleep gradually decreases toward adult levels. By around age 5, children spend about 20 to 25% of their sleep in REM, similar to adults. Young children do report dreams, though their dream reports are often brief and simple compared to adult dreams. A preschool child might report dreaming about an animal or a family member, but without the complex narratives or elaborate scenarios that characterize adult dreams. The developmental psychologist David Fowlkes conducted extensive research on children's dreams, collecting dream reports from children of various ages over several years. He found that younger children's dreams were generally shorter and less story-like than older children's dreams. The dreams of children younger than about 7 often consisted of static scenes rather than narratives with sequences of events. For example, a 5-year-old might report a dream like, "I was at my grandma's house." When asked what happened, the child might not describe any events, just that static scene. In contrast, an older child or adult would typically describe a dream as a sequence. "I was at my grandma's house, and then we went to the park, and there was a dog." This developmental pattern suggests that the ability to construct complex dream narratives develops gradually and is linked to the development of certain cognitive abilities, particularly visuospatial skills and the ability to understand sequences of events. The content of children's dreams also changes with age. Younger children dream more frequently about animals than adults do. This might reflect the prominence of animals in young children's lives through stories, toys, and media, or it might relate to more general aspects of cognitive development. As children move into adolescence, their dreams become increasingly similar to adult dreams in structure and content. Dreams become longer, more complex, and more likely to include abstract thoughts and emotions. Social interactions become more prominent in teenage dreams, which makes sense given the increasing importance of peer relationships during this developmental period. Adolescence is also when some sleep-related changes occur that can affect dreaming. Teenagers' circadian rhythms shift, making them naturally inclined to stay up later and sleep later in the morning. When this biological shift conflicts with early school start times, teenagers often become sleep-deprived, which can affect both the quantity and quality of their dreams. In adulthood, dream patterns remain relatively stable for several decades, though the specific content of dreams naturally changes to reflect current life circumstances. A young adult's dreams might frequently incorporate themes related to career development, romantic relationships, or establishing independence, while a middle-aged adult's dreams might more often include themes related to children, established relationships, or professional responsibilities. One interesting finding is that people tend to dream about concerns that are important but not overwhelming. If something becomes too distressing or occupies too much of our attention during the day, it may be somewhat less likely to appear directly in dreams, possibly because we've already spent so much time thinking about it consciously. As people move into older age, several changes in dreaming occur. Older adults generally report fewer dreams than younger adults, and the dreams they do report are often shorter and less emotionally intense. This might be related to changes in sleep architecture, as older adults spend less time in REM sleep and have more fragmented sleep with more frequent awakenings. However, the decrease in dream reporting in older adults might not reflect a true decrease in dreaming. It could partly be due to changes in memory, as dream recall depends heavily on memory processes that can decline with age. Studies that wake older adults during REM sleep still find that they can report dreams, suggesting they're still having dream experiences even if they don't remember them spontaneously upon morning awakening. The content of older adults' dreams shows some characteristic patterns. Dreams in late adulthood sometimes include more themes related to loss, health concerns, or reflections on the past. However, there's considerable individual variation, and many older adults report rich, vivid dreams throughout their lives. Interestingly, some people report that their dreams become more positive and less anxiety-provoking in later life. This might be related to what psychologists call the positivity effect, a tendency for older adults to focus more on positive information and regulate their emotions more effectively than younger adults. Throughout the lifespan, individual differences in dream recall and content remain pronounced. Some people remember multiple dreams every night throughout their entire lives, while others rarely remember dreams even as children. These individual differences seem to be stable traits that persist across decades. Cultural perspectives on dreams. While the basic neurobiology of dreaming appears to be universal across humans, the way people understand and relate to their dreams varies considerably across cultures. Looking at these cultural perspectives enriches our understanding of dreams and reminds us that the scientific approach is just one way of making meaning from dream experiences. Many indigenous cultures view dreams as important sources of knowledge and guidance. Among various Native American groups, dreams have traditionally been seen as means of communication with the spiritual world, sources of prophecy, or ways to connect with ancestors and spirit guides. Some cultures practice what anthropologists call dream incubation, deliberately seeking dreams for specific purposes. In traditional Aboriginal cultures of Australia, dreams are deeply integrated into spiritual and social life, Dreamtime stories describe the creation of the world and provide a framework for understanding relationships between people, animals, land, and the spiritual realm. In some African cultures, dreams are taken very seriously as potential messages from ancestors or warnings about future events. Dream interpretation is sometimes performed by designated spiritual leaders or elders who have specialized knowledge. The content of dreams might influence important decisions about marriages, conflicts, or community actions. Studies comparing dream content across different cultures have found both similarities and differences. The basic structure of dreams, their occurrence during REM sleep, and certain universal themes like being chased or falling appear across all cultures studied. This suggests that the fundamental neurobiology of dreaming is the same for all humans. However, the specific content, the interpretation, and the importance given to dreams vary considerably. People in Western industrialized societies often view dreams as private, psychological phenomena with personal meaning. In contrast, many non-Western cultures view dreams as having social, communal, or spiritual significance that extends beyond the individual dreamer. In some cultures, people regularly share dreams with family or community members, and the dreams might be interpreted collectively. This contrasts with the more private treatment of dreams common in contemporary Western societies, where people might share dreams with close friends or therapists but rarely discuss them in larger social contexts. The expectations and beliefs about dreams that exist in a culture can actually influence dream content itself. This has been demonstrated in studies showing that when people believe dreams have prophetic significance, they're more likely to remember dreams that seem to predict future events. When people believe dreams reveal unconscious desires, they're more likely to notice and remember dreams that fit that framework. There's also evidence that the specific symbols and themes in dreams can be culturally influenced. While the emotion of anxiety is universally common in dreams, what triggers that anxiety might differ. Someone in a traditional society might dream about displeasing ancestral spirits, while someone in a modern urban setting might dream about missing an important work deadline. Language and cultural categories can shape dream reports as well. When people describe their dreams, they use the concepts and categories available in their language and culture. This doesn't necessarily mean the dream experience itself was different, but it affects how the dream is understood and communicated. Research by anthropologist Barbara Tedlock has explored how different cultures conceptualize the relationship between waking and dreaming reality. Some cultures view dreams and waking life as equally real but different realms of experience. Others see dreams as more real or more important than waking life for certain purposes. The Western scientific view, which generally treats waking life as the primary reality and dreams as subjective mental events, is just one among many possible frameworks. The practice of lucid dreaming, which we discussed earlier, has been cultivated in some cultures for centuries. Tibetan Buddhist traditions include practices related to lucid dreaming as part of spiritual development. The practice called dream yoga involves learning to maintain awareness during sleep and dreams as a way of gaining insight into the nature of consciousness and reality. Similarly, some Islamic traditions have long recognized and discussed what we would now call lucid dreaming. The concept of true dreams that carry spiritual significance has been part of Islamic thought since its early history, and some Sufi traditions have developed practices for cultivating awareness during dreams. These examples show that while the scientific study of dreams is relatively recent, human beings have been thinking deeply and systematically about dreams for thousands of years. Different cultural frameworks have noticed different aspects of the dream experience and developed different techniques for working with dreams. The cross-cultural study of dreams is challenging because it requires navigating different frameworks of understanding. A dream that would be interpreted as a random neural event in one culture might be understood as an ancestor's message in another, or as a processing of emotional concerns in yet another. All of these interpretations might capture something true about the dream from different perspectives. Dreams and mental health. The relationship between dreams and mental health has been recognized for more than a century, since the early days of psychoanalysis. Modern research has revealed complex connections between dream patterns and various psychological conditions. Depression affects dreaming in several ways. People experiencing depression often report more negative emotions in their dreams. They may have more dreams involving themes of loss, failure, or rejection. The continuity hypothesis, which suggests dreams reflect waking concerns, would predict this pattern, as people who are depressed spend more time thinking about negative themes during waking hours. Interestingly, depression is also associated with changes in sleep architecture that affect when and how much REM sleep occurs. Some studies have found that people with depression may enter REM sleep earlier in the night than usual and may have longer or more intense REM periods. This has led to theories that excessive or poorly regulated REM sleep might contribute to depression, though the relationship is complex and not fully understood. Some antidepressant medications affect REM sleep, often suppressing it to some degree. Interestingly, this REM suppression doesn't seem to harm patients and may even contribute to the therapeutic effect for some people. Though this remains a topic of ongoing research, anxiety disorders are strongly associated with nightmares and disturbed dreaming. People with generalized anxiety disorder, panic disorder, or social anxiety disorder report more frequent nightmares than the general population. The content of these nightmares often relates to their specific anxieties, with themes of danger, threat, or social humiliation appearing frequently. Post-traumatic stress disorder has perhaps the clearest connection to disturbed dreaming. Recurring nightmares are one of the diagnostic criteria for PTSD, and they can be among the most distressing symptoms. These nightmares may directly replay the traumatic event, or they may present trauma-related themes in more symbolic ways. The nightmares of PTSD tend to differ from ordinary nightmares in some ways. They may occur during both REM and NREM sleep, whereas typical nightmares occur almost exclusively during REM sleep. They may be less bizarre and more realistic than typical dreams, often closely resembling the actual traumatic event. And they may be accompanied by movements or vocalizations that break through the normal muscle paralysis of REM sleep, as the intense activation partially overrides the brain mechanisms that usually keep us still. Treatment of PTSD often needs to address the nightmare specifically, as they can maintain the disorder by repeatedly re-exposing the person to trauma-related content and disrupting restorative sleep. The imagery rehearsal therapy we discussed earlier was developed specifically for trauma-related nightmares and has become an important part of many PTSD treatment protocols. Bipolar disorder also shows interesting relationships with sleep and dreaming. During manic episodes, people often have a reduced need for sleep and may experience very vivid, grandiose, or bizarre dreams when they do sleep. Some individuals with bipolar disorder report that changes in their dreams, particularly an increase in vivid or unusual dreams, can serve as an early warning sign of a mood episode beginning. Schizophrenia has been linked to changes in dreaming as well, though the research is complex. Some studies have found that people with schizophrenia report fewer dreams or have difficulty distinguishing between dream memories and waking memories. There are also reports of increased reality confusion, where dreamlike experiences intrude into waking consciousness, or where the boundary between sleeping and waking becomes unclear. Some researchers have even proposed connections between the brain processes involved in dreaming and those involved in psychosis. Both involve vivid perceptual experiences that seem real but don't correspond to external reality, reduced prefrontal cortex activity, and acceptance of bizarre or impossible events as normal. This has led to the suggestion that studying dreams might help us understand psychotic experiences, and vice versa. Sleep disorders themselves can affect mental health and dreaming. Insomnia, difficulty falling asleep or staying asleep, is closely associated with anxiety and depression. People with insomnia often report heightened anxiety about sleep itself, which can create a self-perpetuating cycle. Their dreams, when they occur, may incorporate themes of frustration or stress. Narcolepsy, a disorder characterized by excessive daytime sleepiness and sudden sleep attacks, involves disrupted REM sleep. People with narcolepsy often experience what are called hypnagogic hallucinations, vivid dreamlike experiences that occur while falling asleep, and cataplexy, a sudden loss of muscle tone triggered by strong emotions. These symptoms reflect the intrusion of REM sleep phenomena into waking life or transitions between sleep and wake. Sleep apnea, where breathing repeatedly stops and starts during sleep, disrupts sleep architecture and can affect dreaming. People with untreated sleep apnea often report poor sleep quality and may have dreams incorporating sensations of suffocation or struggling to breathe. Treatment with continuous positive airway pressure or CPAP machines often leads to reports of more vivid dreaming, possibly because people are finally getting adequate REM sleep once their breathing is normalized. The therapeutic use of dreams has evolved considerably from the early psychoanalytic approaches. While some therapists still use dream analysis as part of their practice, they typically do so in ways that are quite different from classical Freudian interpretation. Modern dream-focused therapy often emphasizes the dreamer's own associations and interpretations rather than imposing a fixed symbolic system. The therapist might ask what various dream elements mean to the specific individual, exploring the emotions and personal connections rather than assuming universal symbols. Some therapists use dreams as a way to access emotions or experiences that might be difficult to talk about directly. A client who has trouble expressing vulnerability might be able to discuss a dream about being lost or unprotected, and through that discussion, access and work with those feelings. There's also interest in using dreams for problem-solving and insight in therapy. Sometimes when people are stuck on an issue in waking life, their dreams might present the problem from a different angle or suggest possibilities they haven't consciously considered. While this isn't about treating dreams as magical or prophetic, It does recognize that the dreaming mind makes different kinds of associations than the waking mind and might offer useful perspectives. The puzzle of dream interpretation, the question of whether dreams have meaning, and if so, what kind of meaning, remains one of the most debated topics in dream science. Different frameworks offer different answers, and perhaps the truth is that dreams can have multiple types of meaning simultaneously. From a purely neuroscientific perspective, dreams are the subjective experience of specific patterns of brain activity during sleep. The content of dreams arises from the activation of various brain regions, particularly those involved in memory, emotion, and visual processing. In this framework, asking what a dream means is somewhat like asking what a particular pattern of neural firing means. It's the process itself rather than a message to be decoded. However, even within this framework, dreams can be meaningful in the sense that they reflect what's been happening in your brain recently. If you've been learning something new, experiencing stress, or processing emotional events, your brain's patterns of activity during both waking and sleeping will reflect those experiences. Your dreams, as products of that brain activity, will incorporate elements of those experiences. The memory consolidation perspective adds another layer of meaning. If dreams are part of how the brain processes and integrates new information, then dream content might reveal what your brain is working on consolidating. A dream about a recent event might indicate that your brain is strengthening that memory. A dream that combines elements from different time periods might reflect your brain making new connections between related experiences. The emotional regulation perspective suggests that dreams have meaning related to your emotional processing. The emotions you experience in dreams and the way dream narratives work through emotional themes might reflect your brain's efforts to regulate and integrate emotional experiences. In this view, a dream isn't necessarily sending you a message, but it is doing important emotional work. Some researchers have proposed that dreams might serve a problem-solving function. While you sleep, your brain continues to work on problems and questions that occupied you during the day, but it does so in the unconstrained, associative way characteristic of the dreaming mind. Sometimes this can lead to genuine insights or creative solutions. There are numerous anecdotes of important discoveries or creative works that reportedly came from dreams. Beyond the examples of Kekulé and How mentioned earlier, Paul McCartney claimed the melody for Yesterday came to him in a dream. Mary Shelley reportedly conceived the core idea for Frankenstein from a vivid nightmare. The golfer Jack Nicklaus once credited a dream with helping him fix his golf swing. While these stories can't be definitively verified, research supports the idea that REM sleep can enhance creative problem solving. In one study, people who were allowed to enter REM sleep before being retested on creative problems showed more improvement than those who stayed awake or had NREM sleep only. The key may be that the dreaming brain makes different kinds of connections than the waking brain. During waking thought, our prefrontal cortex keeps our thinking relatively logical and constrained. During dreaming, with the prefrontal cortex less active, more unusual connections can form. Sometimes these connections are nonsensical, but occasionally they might lead to a genuinely useful insight or a creative combination of ideas. From a psychological perspective, dreams might have personal meaning that's worth exploring, even if they don't have hidden messages in the Freudian sense. The themes that appear in your dreams, the emotions you experience, and the ways you interact with dream scenarios might all reflect aspects of your psychological life. For instance, if you frequently have dreams where you're trying to reach somewhere but face obstacles, that pattern might reflect a general feeling of frustration or blockage in your waking life. You don't need to believe that the specific obstacles in the dream symbolize specific waking problems in some fixed way. Rather, the dream pattern might be worth noticing as a reflection of your current emotional state. Some people find value in keeping dream journals, writing down their dreams regularly and noticing patterns over time. This practice doesn't require believing that dreams have prophetic power or hidden meanings. It's simply a way of paying attention to another stream of your mental experience and seeing what you might learn from it. Research has found that people who regularly record their dreams often become better at remembering them. This isn't because more dreams are occurring, but because the practice of focusing on dreams upon waking strengthens the neural pathways involved in dream recall. Over time, people often notice recurring themes, characters, or settings in their dreams that they hadn't been aware of before. The question of whether dreams can be prophetic, accurately predicting future events, has been investigated scientifically, and the evidence doesn't support the idea. What does happen is that people sometimes remember the few times a dream seemed to predict something and forget the many times dreams didn't correspond to any future events. This is a common type of memory bias. Additionally, dreams often incorporate our concerns and expectations about the future, so they might sometimes align with what actually happens, not because they're prophetic, but because they're reflecting our accurate intuitions or realistic expectations. If you're worried about a relationship ending and dream about a breakup, and then the relationship does end, the dream wasn't necessarily prophetic, it was reflecting concerns you already had on some level. Probability also plays a role. Over a lifetime of thousands of dreams, a few will coincidentally align with future events just by chance. The human mind is very good at finding patterns and making connections, so we're primed to notice and remember these coincidental matches while forgetting the vast majority of dreams that don't align with anything. What seems clear is that dreams don't have a single, simple kind of meaning. They're not coded messages that can be decoded with a dream dictionary. They're not random noise devoid of any significance. They're complex mental experiences that reflect the activity of your sleeping brain, incorporating your memories, concerns, emotions, and the neural processes involved in consolidation and regulation. Whether you choose to pay close attention to your dreams, view them as interesting curiosities, or largely ignore them is a personal choice. From a scientific standpoint, all of those relationships with dreams are legitimate. What matters is understanding what dreams actually are: natural phenomena produced by the sleeping brain, with connections to memory, emotion, and cognition that we're still working to fully understand. Special dream phenomena beyond ordinary dreaming. There are several unusual dream-related experiences that deserve attention. These phenomena are less common but provide additional insights into how the sleeping brain works. We've already discussed lucid dreaming in detail, but it's worth noting that there are gradations of lucidity. Some people report what researchers call pre-lucid dreams, where they have a vague sense that something is odd or dreamlike, but don't quite achieve full awareness that they're dreaming. Others report very high levels of lucidity, with complete clarity about being asleep and extensive ability to control the dream. False awakenings are another interesting phenomenon. In a false awakening, you dream that you've woken up. You might dream about getting out of bed, starting your morning routine, perhaps getting dressed or eating breakfast, only to actually wake up and realize that the waking up was itself part of a dream. Sometimes this can happen multiple times in succession, creating a layered experience of false awakenings within false awakenings. False awakenings can sometimes occur in conjunction with lucid dreaming. A person might become lucid in a dream, then dream they've woken up, losing the lucidity in the process. This can be frustrating for people trying to maintain lucid awareness throughout a dream. Sleep paralysis, which we mentioned earlier, deserves more discussion because of how commonly it's misunderstood. During sleep paralysis, a person is conscious or partially conscious but unable to move their body. This typically happens either when falling asleep or when waking up, and it occurs because the muscle paralysis of REM sleep hasn't yet turned off even though consciousness has returned. The hallucinations that often accompany sleep paralysis can be quite vivid and fall into several categories. Intruder hallucinations involve the sense that someone or something is present in the room. Incubus hallucinations involve a feeling of pressure on the chest and difficulty breathing, often interpreted as something sitting on the chest. Vestibular motor hallucinations involve sensations of floating, flying, or out-of-body experiences. These hallucinations have been interpreted in culture-specific ways throughout history. The term nightmare originally referred specifically to sleep paralysis experiences, with mare deriving from a Germanic word for a demon or goblin that was believed to sit on people's chests while they slept. Different cultures have different traditional explanations, from alien abductions in contemporary Western culture to spirit visitations in various traditional societies. Understanding the neuroscience of sleep paralysis can make the experience less frightening. The sensation of a presence may relate to hyperactivity in brain regions involved in threat detection. The pressure on the chest comes from awareness of the restricted breathing that's normal during REM sleep. The vivid hallucinations reflect the dreamlike brain activity that's still partially ongoing. Sleep paralysis is relatively common, with surveys suggesting that about 8% of people experience it at some point in their lives. Although it is more common in patients with narcolepsy, it can occur in anyone, especially in cases of sleep deprivation. Thank you for being with us. Subscribe when you wake up. Sleep well. See you soon.